Hi everyone. This video is going to specifically talk about synthetic division, which is a very fast way of dividing polynomials where our divisor is not a monomial. So I got a bunch of text here. I'm just going to read it real fast. And then I'm going to show you the synthetic division technique that we're going to use. And the best part is because this is a video, you can pause it, rewind, and you can kind of see how the flow goes because otherwise I would be writing like a wall of text. And I think by showing you, it's better than just typing things out. So recall that when we use long division on a problem like the quantity 2x to the third minus 3x squared plus 4x plus 5 divided by the quantity x plus 2, this is going to require us to do the long division algorithm 3 times as shown below. So how do I know I got to use it 3 times or the long division algorithm 3 times? Well, if I look in my, and I'm going to write this here, if I look in my dividend, that's what this is. I noticed that the highest degree in that polynomial is to the third power. So I know long division 3 times. And while we're at it, the x plus 2 is going to be called our divisor. Okay. And as you can see here down below, I have worked out the long division technique for this. And like I said, you got to do this 3 times. And it takes a lot of time to do this. It's very tedious. You could easily make a mistake. So I'm going to show you a much more efficient way to do this. And it's called synthetic division. Okay. So here's the technique. These are the steps. This is like the cheat code. All right. This is, if I were studying this, I would put it on a note card. And I want you to make sure that, as we move through these steps, you completely understand what's happening. So the first thing is that we got to check to make sure our divisor is in the form x minus c, or in other words, x minus a number. So, like for example, and I'm going to scroll up above real fast, our divisor right here is x plus 2. So we almost have what we need for synthetic division. So if I scroll back down now, you will see in red it says if you have x plus c, rewrite it as x minus negative c. Okay? So when I'm going to do that problem on the board again, but I'm going to use synthetic division and you'll see me actually rewrite this. The second thing, our dividend. So our dividend must be in decreasing degree with no missing terms. So if we read in red, so like for example here, if you have x to the third minus 2x plus 3. First, that is in descending degree. So I can put like a little check mark, like, yes, it's in descending degree. However, I'm totally missing terms. And I want you to note that the x to the second, like if you were thinking about like descending degree, like x to the third, you would expect x to the second, then x to the first, and then a constant term. So we are missing x to the second. Therefore, we're going to rewrite as x to the third plus 0x to the second minus 2x plus 3. We have to add in, we have to add in the missing term. And we do that just by putting a 0 in front. That doesn't change the problem at all. It's just now you have that missing term identified. Okay? The third thing we're going to do is we're going to set up what our synthetic division will look like. Okay? So to do this, we kind of use like this little chart here that I have. And I'm going to be filling in this with numbers and everything. But in general, whatever C happens to be from your divisor, that goes on the left-hand side. Then you're going to use the coefficients of your dividend. And then you're going to draw like a line, like right here. This is the line I'm talking about. And finally, in the lower right-hand corner, you could put like this little box. Sometimes some books show this, some books don't. I'm going to write it in so you know that's what it is. But whenever I use this technique called synthetic division, that is where the remainder is going to go. And then step 4 is straight up use the technique. Okay? So let's go ahead and let me show you an example doing this. And we're going to use the example that we had at the very start. So we're going to divide 2x to the third minus 3x squared plus 4x plus 5 by x plus 2. So, step 1, let's check our divisor. We know we have x plus 2, however, it has to be x minus. So I'm going to rewrite this as x minus negative 2. Because if you think about it, a negative and a negative back to back make it positive. So right now I know c is going to equal negative 2. Okay? Step 2, we're going to check our dividend. Well, if we check our dividend, 2x to the third minus 3x to the second plus 4x to the first minus plus our constant. We know everything is good here. It's in the form that we need, descending degree, no missing terms. So that's great. Step 3, and I'm going to write step 3/4 because we kind of do them at the same time. Okay? So first, I'm going to set this up. So I'm going to draw my little, semi boxes. I'm going to draw this line and write my remainder. Across the top, c is equal to negative 2, so I'm going to put a negative 2 there. And then the coefficients in the dividend will be 2, negative 3, 4, and 5. Okay? And now here's the technique, and this is where I said I can write this out, but it would be like a wall of text. So maybe just watch, rewind the video, watch again, rewind the video, do it yourself along with the video. That way you kind of get the flow of this. But the first thing we always do is we drop down this first number. No matter what, just drop it down. Now, the next thing we're going to do is we're going to move diagonally, okay? So negative 2 times 2, we're going to multiply. And negative 2 times 2 is negative 4. That answer goes right here, all right? So if you think about it, all right, it's kind of like if I get rid of that right there, it's kind of like a flow. It's like you move diagonally down to the right, and then the answer goes upstairs to the right. All right, so it's like a little flow. It's like a little, if you think about it here, it's like a little letter U. All right, that's the way we're going to do this. Okay? Once we do this first step, I'm going to erase. The next thing we're going to do is come straight down, and we're going to add. Negative 3 plus negative 4 is negative 7. And the entire process repeats over again. Okay? So what do I mean by that? We're going to take negative 2 and multiply it by negative 7. So that's going to give me positive 14. Then we're going to come straight down. We're going to add. That's going to give me 18. Process repeats over again. Negative 2 times 18 is negative 36. And 5 plus negative 36, coming straight down, we're going to add, is negative 31. All right, synthetic division is complete. But now, how do we write the answer? Here's how we write our answer. We know that our dividend had a degree of 3. In other words, this was 2x to the third minus 3x to the second plus 4x plus 5. Anytime you synthetically divide, your result will always be 1 degree less. So this is going to be degree of 2. In other words, the polynomial is going to be a degree of 2. And these numbers right here, they are the coefficients of my quotient, meaning the answer. So if I move from left to right, I get 2x to the second minus 7x plus 18 with a remainder of negative 31. And that's how we do synthetic division. All right? Now, there is a proper way to write the quotient, okay? And I'm going to write that below here in black. So, the proper way to write the quotient is in the form quotient plus your remainder divided by your divisor. So technically, this answer is really 2x to the second minus 7x plus 18 plus negative 31 over x plus 2. All right? And that is the answer. Now, I know sometimes in WebAssign, they kind of want things a little bit differently. So in WebAssign, all right, if they have the following, it'll say quotient with a box and then remainder with a box. All they want for the quotient would be 2x to the second minus 7x plus 18. And then for the remainder, all they would want is negative 31. If they don't separate, then they want this upstairs. They want that answer upstairs. All right. So like I said, you just got to be careful. Okay. Now, some of you hopefully are sitting there and asking yourself, well, why do we write the remainder here like this? All right. And technically, this is the way that you should have been taught how to write the remainder. The problem is when you were learning division back in the day, you were learning how to do the division using like a grouping theory. In other words, if I had 15 cookies, okay, and there were only 2 of us, so 2 people eating, the question would be, how many cookies will each person get equally? Now, we can probably do this in our head, all right? Each person would get 7 cookies, but I'm going to do the long division here. So 2 would go into 15 7 times with a remainder of 1, all right? However, if you were to type this into your calculator, if you were to type in 15 divided by 2 into your calculator, it would say 7.5. The 0.5, everybody, is coming from the fact that you have a quotient of 7 plus your remainder divided by your divisor. 7 plus 1/2. And we know 1/2 is 0.5, and 7 plus 0.5 is 7.5. So this is the proper way in how to write your actual results when you're dividing. It's just, like I said, a long time ago, we were concerned with, do you understand what division is, which is creating equal groups. And then you were telling me what's left over. Like, okay, well, this one cookie I couldn't put in a group because we have 2 people, but only 1 cookie. So we split it in half. Okay. Now, I'm going to go ahead and I'm going to do some examples using synthetic division here. Okay. All I want you to do is kind of, like I said, follow along and just make sure you are understanding the process. Okay. So here's another example. So let's go ahead and let's divide 5x to the second minus 3x minus 36 by x minus 3. Okay? So once again, step 1, we have the form x minus c. So in this case, c equals 3. You don't take the sign in front. It's strictly the number. All right? Do not confuse this with the previous example. If you need to go back and look at the previous example to see the difference, just rewind the video. Step 2, our dividend, 5x to the second minus 3x minus 36, is in descending degree. No missing terms. Check. That's great. Now, step 3 and 4, we're going to set it up and then do the technique. So 3, 5, oops, it's a bad looking 5, negative 3, negative 36. We're going to drop the first number down, and we're going to create a little box here and write remainder. Now I'm going to draw the arrows just so you can see the flow. I'll be writing in a red marker. because in black is like the setup. This is the setup right here. Everything in black is the setup. Now, technique. 3 times 5, 15. Now we're going to add straight down. -3 plus 5. I'm sorry, -3 plus 15 is 12. Process repeats. 3 times 12 is 36. And -36 plus 36, going straight down, is 0. So here's an example where we have 0 as a remainder. That's great. Remember, we started with a dividend, degree 2. That's right here. I'm going to highlight it in blue. There it is right there. Highlighted it in blue for us. Our quotient will start with a degree of 1. Remember, it's always one less. So, moving from left to right, 5x plus 12. Notice there is no remainder, so we don't write anything. That's it. Synthetic division in all of its glory. Very fast, very efficient. Here's another example. This one, we're going to do x to the third minus 8 divided by, let's do x minus 2. Okay? So here, step number 1, x minus c. Well, we have that. We have x minus 2, which implies c is equal to 2. Now, step 2, our dividend, x to the third minus 8. We are missing terms. So, x to the third, and add in your missing terms. Plus 0x to the second, plus 0x minus 8. So I had to add in 2 missing terms. Step number 3 and 4. We're going to make our setup here. Everything in black is kind of like mechanical at this point. 1, 0, 0, -8. Bring down the first term. Right remainder. In red is going to be me actually doing it now. So 2 times 1 is 2. 0 plus 2 is 2. Process repeats. 2 times 2 is 4. Add straight down, we get 4. Finally, 2 times 4 is 8. And -8 plus 8, adding straight down, 0. So once again, we have an example here where we have 0 remainder. That's fine. Our dividend started at degree 3, which means our quotient is going to be degree 2. And moving from left to right, we get 1x to the second plus 2x plus 4, or simply x to the second plus 2x plus 4. So hopefully you can now see just how special this technique actually is. All right. And what makes this so great is it is just so much faster. Okay. I'm going to do one more example here for us because I don't want this video being too long. So let's synthetically divide -9x to the fourth plus 10x to the third plus 7x to the second minus 6 by x minus 1. All right, step 1, x minus c. We have that. We have x minus 1, so c is going to equal 1, okay? Step 2, we got to worry about that divisor, or I'm sorry, dividend. I keep saying that by accident. -9x to the fourth plus 10x to the third plus 7x squared. We are expecting x to the first, but we don't have that. So we're going to add it in, x to the first minus 6. So we had to add in that missing term. All right. Now step number 3 and 4, set up in synthetic algorithm. So put a 1 there. Let's write out these coefficients. -9, 10, 7, 0, -6. Always drop the first coefficient down. On the far right-hand side is going to be the remainder. Take a deep breath. Okay, here we go. 1 times -9 is -9. Add straight down. 10 plus -9 or 10 minus 9 is 1. Process repeats. 1 times 1 is 1. 7 plus 1 is 8. Process repeats. 1 times 8 is 8. 0 plus 8 is 8 again. Process repeats. 1 times 8 is 8. And -6 plus 8 is +2. I guess I can write this a little bit neater down here. There we go. That looks good. All right. So, recall. We started our dividend with a degree of 4. Therefore, our answer, our quotient, will be degree of 3. And just move left to right as you go. -9, x to the third, plus 1, x to the second, plus 8, x to the first, plus 8, plus our remainder over our divisor. And that's it. This is how synthetic division works. I hope you can appreciate, like I said, just how fast this is. Now you don't have to use synthetic division anymore. The key, all right, this is the key. Our divisor must be in x minus c form. If you do not have your divisor in x minus c, you cannot use synthetic division. I will make sure it's in this form. That way you can practice it. See you in the next video.